everyone's lunch? How was everyone's lightning talk submissions? You did submit a lightning talk over lunch, didn't you? Friendly reminder, they will close at the end of the next break. You got to be in it to win it. Reminder that you get to have a choice of a selection of different packed publishing PDFs if you submit a talk and present it. You got to actually do the work. We have Ollie, and he will be teaching us about how to secure Python web apps. So let's make him feel welcome.
Cool. Hello. Welcome to Securing Python Web Apps. I'm Ollie. As was just said, I'm a cloud-native security engineer. Still not entirely sure what that means. New job title for me. And I work at a company called Control Plane. And Ollie the Ninja is my handle on everywhere. So if you want to find me, that's where you can find me. The QR code will be back up at the end as well for the slides. So I do cloud-native security. I have to thank my employer for letting me be here, because I submitted this talk last year, and I joined them 3 months ago, and they're like, yeah, it's fine, you can go to a conference. Basically, we do cloud-native security, DevOps done well. So we help teams secure their platforms and their pipelines, and we do a lot of turning things into code that were previously manual processes so that we can help them be more secure. Anyway, today we're going to talk about hardening web applications for the internet. I'm going to focus on Django because that's what I have the most experience with. But I'm going to try and keep it fairly generic so that if you're using a different framework, or you might not even be doing Python all of the time, hopefully this will still be helpful for you. We're going to talk about how we secure web applications as well as why, because I'm a big fan of knowing why we're doing things. I find it helps me, it helps with the understanding of what we're doing if we know why we're doing it. I'm also aware that while I do security full-time, most of you probably don't do security full-time. As much as we can thank Laura for helping us understand why security is an important part of what we all do in IT. I'm going to try and use the 80-20 rule, give you things that will give you the most bang for your buck, things that you can do in a short period of time that'll have a large impact on your security posture. And I'm going to give you a bunch of resources and reference documentation and links to things so that you don't have to remember everything I said. You will hopefully know where to go to get access to that information again. Cool. So why are we talking about security? I don't think I need to dwell on this too much because I think Laura did an excellent job of that yesterday. But we are, I guess the main thing is the internet's a hostile environment. Anyone who's spun up a web server on AWS and opened it up to the internet and watched the access logs will know that there's constantly people scanning for web applications and trying to find vulnerabilities. So before we deploy an application into production, it's probably a good idea to make sure that it's secure and to make sure that it's going to perform well and that it's not going to fall over 5 minutes later. These aren't my words. Does anyone recognize them? They're the first line from the Django deployment checklist, which I only discovered recently listening to the Django podcast, and is apparently something that a lot of people don't know exists. So it's part of the Django documentation, and it takes you through all of the things that you should be thinking about if you're going to put a Django application into production. So if you don't take anything else away from this talk, know that there is a checklist that you can use that'll give you that baseline, making sure that you're turning on all the security features that may have been turned off to make development easier, and help you be more secure in production. It also shows you how to use the built-in checker in Django to check your production settings and make sure that there's nothing ridiculously open and insecure in there, to help you with that as well. If you're using Flask, Flask similarly has some security documentation that's actually really good at taking you through all the basic things that you need to make sure you do to keep your Flask app secure. Flask being a bit more of a choose your own adventure, import your own libraries type thing rather than having everything included by default. There's a really good library called Flask Security 2, which is a roll-up of a bunch of little libraries that do some really good best practice security things for your application. So even if you don't use that library directly, it's a good place to start to find the resources that you need to make your application secure. We're going to move on a little bit and talk about things that are less specific to to the frameworks. I'm going to talk about the OWASP Top 10. If you haven't heard of the OWASP Top 10, the Open Web Application Security Project, which I put up there because I struggle to read it out every time. It's an organization that gathers data from around the world to find out what the most common security vulnerabilities are in web applications. They just brought out a new version at the end of last year. And yeah, it's based on data from around the world, so we know that these are the most common vulnerabilities, which means if we're thinking about what vulnerabilities might exist in our web applications, it's a really good place to start. I'm also a big fan of checklists, especially if you're not doing this on a day-to-day basis. Being able to come back to this and see and check what are the sort of vulnerabilities that I should be looking for. This is a really good place to start. So these are the top 10 as of the end of last year. And I don't expect you to remember them all, because if you Google OWASP Top 10, they'll be there. I'm just going to talk about the top 6, because I have just over 20 minutes left, which means I think I have like 3 minutes per top thing, so let's get going. The top one is broken access control. I love this GIF. Cool. So broken access control is all about when someone who shouldn't have access to data can get access to data, or someone who shouldn't be able to can add data to your system or modify it or delete it. And there's all sorts of ways that that can happen. I'm not surprised that this used to be number 5 up until the end of last year. Now it's number 1. And I'm not surprised that it's gotten to that point, because it's the hardest one to fix. It's the only one on my list that I don't have a clear answer to, that I can say, hey, if you turn these things on and check these things, you'll be fine. Just to give you a quick example, here's my super admin dashboard for my super admins. I've left out the business logic for brevity, but it takes a request and it returns a response, and it has a decorator at the top that makes sure that only super users can access it. In the bottom one, it's the same thing, but I forgot the decorator. And what happens in that scenario? Anyone can access it. Most frameworks fail open because it's pretty tricky to check whether you've done your access control, because there's so many different ways to do it. But this is the sort of thing we're talking about, where even the simple act of forgetting to put the access control on there on a particular view, or maybe you comment it out to test something and then forget to uncomment it again. I've done that and it's ended up in production, and then I've gone, oh, I need to put that back on. But there's a few things that you can do. So number 1, and Laura talked about yesterday about how we probably all need to do better at testing, is test to make sure that the correct access is being applied, that people who can't access things, that shouldn't be able to access things, can't access them. And it might seem like that's a big challenge, like it's going to be a lot of work to test every single edge case, but actually a couple of basic tests for every view you have that tries to access it without being logged in, maybe tries to access it with someone, with a user that shouldn't be able to access that view, will get you a long way to making sure that you don't accidentally leave a view open. I've had some limited success with having some middleware that checks that the response has an annotation that says this response has been checked for access control. I think if you're smarter at Python than I am, you can probably figure out a way to check all your routes and make sure that there's some sort of decorator applied that says that is checking access control. And I was talking to Curtis yesterday, and he mentioned that actually you can implement database row level security, and there's ways of doing that. So it's probably also a bit involved, but it's another way of doing it. The tricky thing with access control is that it all depends on what your business logic is, how you're using your framework, and all of that sort of thing. So the main thing here is test your access control. Make sure you have something in place that if you accidentally leave something open, you'll get notified about it. Cool. The next one is cryptographic failures. Just like this lock failure, because you can just reach around and unlock it. So cryptographic failures are this OWASP. This is the second one on the OWASP top 10. And it's all about either cryptography not being applied correctly. So maybe you're using out-of-date cryptography. Maybe you forgot to turn the cryptography on. You thought something was being encrypted and it's not. It's also about making sure that the secrets that cryptography relies on are being kept secret. And the final one is making sure that we're applying cryptography where it needs to be, and that we understand the difference between hashing and cryptography, and that we're using the right tool for the job. So using modern cryptography, most of the Python frameworks are pretty good. Like the built-in, how they store passwords, how they encrypt tokens and things are pretty good. So if you're using the defaults, you're probably already in a good place. And what I've seen a couple of times is that people have overridden the defaults for some reason some years ago, and the defaults have changed and gotten better, but they haven't updated. Keeping secrets secret, I'm preparing a whole nother talk on how to make sure your secrets are secret, but don't commit them to source code would be a good start. And don't confuse encryption for hashing, as I said. Number 3 is injection. It used to be number 1 up until the end of last year. When I submitted this talk, it was number 1. And I was going to start my talk by saying that if you're using one of the Python frameworks and you're using the Django ORM or SQL Alchemy, you probably don't have to worry as much about at least SQL command injection. And then they moved it to number 3. But we can still talk about it. In case you're unfamiliar, command injection, this is SQL injection, but it applies equally to NoSQL databases. There's all sorts of commands that might be able to be injected into your application, but it generally relies on you trusting user input and not sanitizing it properly. So if we have this check that is a little bit contrived, but usually it'd look a little bit more complicated, but we want to fit it into a slide. Select a user from a database if the username exists. And the users managed to make the username or 1 equals 1. And so when we concatenate it all together, we end up with, does the username exist or does 1 equal 1? And of course, it's going to always return true. So application broken, access control broken. What we should be doing, and Steve mentioned this in his Flask talk yesterday, is at the very least using parameterized queries. So rather than injecting the string directly into your query, you pass whatever library you're using to talk to your database, you pass it a parameterized query, and you give it the parameters separately. And it'll make sure that everything's escaped properly. And with that, you pretty much eliminate, I don't want to say eliminate because someone's going to say that there's still ways to get around it, but it's that 80-20 rule. You're going to significantly reduce the likelihood of introducing an injection vulnerability if you're using your database queries properly. And if you're using an ORM, like the Django ORM or SQL Alchemy, then that's going to handle that for you as well. Yeah, what I just said. The other big injection vector is when a user can input something, and some JavaScript, and it ends up being rendered in someone else's browser as JavaScript and executes. It's called cross-site scripting. And if you're using Django templates or Ginger or encoding your output properly, then again, it's going to significantly reduce the chance of you introducing that type of vulnerability. So a lot of this is about making sure that you use the tools that are available to you and to, use them properly. Making sure if you read the documentation on Django templates, there is a part on cross-site scripting and how to prevent that as well. Number 4 is insecure design. This one's pretty straightforward. You should be thinking about your security, the security of the thing you're building from the start. Used to be called shift left, where that seems to be less popular now. We're now talking about making sure that security is in every part of the software development lifecycle. But generally, we want to make sure that we think about how we're designing the application and how someone might abuse our application from the beginning so that we're not having to go and change things later. It's always easier to build it right from the start, even if it takes a little bit longer than it is to go back and fix things right before you want to go into production, and then things get delayed. Number 5 is security misconfiguration. This one, I was practicing my talk with my girlfriend, who's not a developer, but does IT things, and she was questioning why this would even be in here, because of course people check their configuration, right, before they go to production, yeah? Everyone checks it, and you also check it every time there's like a major version change, because the settings could have changed and there could be extra settings that you haven't turned on, right? Yeah, cool. I like that people are giggling, because there's a reason that this is the OWASP number 5 vulnerability, even though it's checking your settings. I saw this on a community Slack the other day. Basically, a tester was testing a web application and trying to see how they could manipulate the authentication token and it would still let them in. And after about half an hour of starting with a legitimate-looking token and working backwards, they realized that token validation was turned off completely, presumably for some sort of development reason, and had never been turned back on. And so they could pass it anything they liked, and it would just let them in. One-line bug, one-line fix. So taking the time to check through your configuration, maybe look at the documentation. I know Django has some really good docs on all of the different settings that are available, and explanations on why, what they do and how they do it. Just taking a little bit of time, taking an hour or two to go through all those and making sure that they're set correctly can save you a lot of headache and potentially a breach later on down the track. The last one that I'm going to talk about today is vulnerable and out-of-date components. I'm a big fan of dependency management, and I just find the whole thing of automating updating dependencies and tracking them and things quite interesting. Laura talked yesterday about third-party dependencies and supply chain attacks and things like that. It's a really important thing, right? This is, for example, the Django release timeline, and it goes out to 2025. So we know in advance that there's going to be changes and we're going to have to update. Sometimes it feels like nobody planned to update the application after it goes live, but we know in advance that this is going to happen. Not all of our dependencies will have a nice timetable like this, and just because the LTS version has 3 years of support doesn't mean that we won't need to apply bug fixes and things like that. If we're using the non-LTS versions, then we're going to need to plan that we need to do an update every 9 months. We know this in advance, so if we can plan for it, that's going to make life a little bit easier. I'm also a big fan of pinning dependencies, because we want to make sure that we have control over how our application's built, what's in there. We don't want one build to the next updating a dependency without us knowing about it and breaking something, and it takes a while to figure out, was it me, is it because that library version changed? But we also need to automate the process of updating them. And that's a spectrum anywhere from having a script that gets run once a week that checks for outdated dependencies. Pip has that built in. You can check if any of your libraries are out of date. Pip tools is a great little library that will help you to pin and upgrade dependencies. And if you want to use something a little more off the shelf, then GitHub has their Dependabot. Mend, formerly White Source, has their Renovate tool, which is a great helper in that it will just send you pull requests every time there's an update for something. You can choose whether you apply it. You can choose whether you automatically have your test suite run against it to make sure it doesn't break anything. And Sneak is also a great tool for scanning what you have and making sure that none of your dependencies are vulnerable. Laura talked yesterday about, maybe you don't want to update. Maybe you know that even though there's a new version that has a CVE associated with it, you're not using that part of the library, and so you're not vulnerable to that vulnerability. But you still need to go through and know that that update is there, and maybe even write down somewhere that you've checked it, and you know that you're not affected by that vulnerability, and there's a good reason that you don't want to update. Also makes it a lot better if you get a security assessment done down the track and you can come in and say, look, we know we've got these components that are not the most up-to-date version, but we've also gone through and checked that we're not affected by the vulnerabilities that are published for them. Check that I don't have anything else in my notes. So really important that we're doing this deliberately. The other thing is, Laura talked about all the different ecosystems, and I'm only talking about pip here, but if you have JavaScript on your front end, then you have a whole nother set of dependencies over there. And then if you have Docker images, you presumably have an operating system that everything's running on, you're going to have a whole nother set of dependencies there. So there's a lot of things that can get out of date and cause you to become vulnerable without you realizing it. So having a process in place to check your dependencies and make sure that you're not vulnerable is really important. So to summarize, keep your dependencies up to date, or at least know that when there are updates. Check your settings to make sure that they're set correctly. Think about how you're designing your application and make sure that you include security in your design from the beginning and throughout your development lifecycle. Make sure you parameterize your queries. Don't use format strings, as Steve mentioned some of his students were doing yesterday. Use modern cryptography. Often that's the default. And make sure you keep those secrets secret. Test your access control to make sure that people can't do things that they're not meant to be able to do. And read the documentation, because honestly, I'm sure the other documentation for a lot of the other frameworks is great too, but I've read a lot of the Django stuff and it really is good. It's well written, it explains things clearly as well. It doesn't just tell you do this, it tells you why it's important. Yeah, that's my talk.
We have a few minutes for questions.
Yep.
You have no online questions. Are there any in-person questions? I have a microphone and I can be made to run all around the venue if people have questions.
If you don't want to ask in front of the crowd, I'm going to be around for the rest of the conference, online at Ollie the Ninja, and yeah.
Going once?
Either I explained it really well or I explained it really
terribly.
terribly.
Oh no, absolutely. Everything was absolutely perfect and everyone knows exactly what to do about the top 6 of the OWASP top 10. And next time Kiwi PyCon's around, you'll do the other 4?
Well, yeah.
Cool. All right, let's thank Ollie again.
Thanks.